Hello everyone. We had in our last sessions lot of things. I should say that actually those sessions for you must have been quite heavy because the kind of treatment we give here to trigonometry, you haven't seen it before. So obviously, I expect that you will take time to get adjusted to the kind of treatment now we are giving. Also, if you recall, we have done lots of formulae like we have done factorization, defactorization, multiple angle formulae, allied angle formulae, in addition to graphs of sine, cosine, and those domain and range and identities. So many things by now we have already done that now it's high time that we start solving problems. And when I say that we start solving problems, I mean that it is like the place where we can apply like whatever we have learned by now. So let us start with the problems. Okay. So I start with first question, and that first question is that if tan 6 theta equal to p by q, then and then one expression is given in terms of p and theta and q, and that expression is half p times cosec 2 theta minus q sec 2 theta, and this expression's value we have to write in terms of p and q. Now, when you read this question, what comes to your mind? That I am asked to eliminate theta. This is something what you can understand. Now, also, tan 6 theta is given to be p by q. Now, there could be questions that how I start with actually eliminating theta. Now, when I see that cosec 2 theta, sec 2 theta, I can at the most think at this moment that I will write that cosec 2 theta as 1 upon sine 2 theta. I will write that sec 2 theta as 1 upon cos 2 theta. At least that is there in my mind. But then to eliminate this, there has to be something additional. So what I do, I will multiply and divide by plus minus under root p square plus q square. Now, why do I do so? Maybe in the following steps you will understand. Now, I multiply and divide by under root p square plus q square, and that outside I have written plus minus sign, and that plus minus sign I am just keeping for actually since we do not know that which quadrant angle will lie, etc. So just to be on safer side, I am writing there plus minus also. Now when we see that p upon under root p square plus q square, and when I see there as q upon under root p square plus q square, some mental calculations if you do, you will understand that p square upon under root p square plus q square whole square means p upon under root p square plus q square whole square I'm talking about. And q upon under root p square plus q square whole square. If I add these two, you're going to get answer as 1. So it is like sine square theta plus cos square theta equal to 1 kind of thing I'm expecting there. That means, am I allowed to write p upon under root p square plus q square as sine theta or q upon under root p square plus q square as cos theta? Am I allowed to write? That is to be seen. Also, if tan 6 theta equal to p by q, that information we have not yet used. Then, what about sine 6 theta and cos 6 theta? Just stretch your mind and try to connect that sine 6 theta and cos 6 theta to the quantities p upon under root p square plus q square and q upon under root p square plus q square. You would realize that one of them can be replaced by sine 6 theta, then other would be replaced by cos 6 theta. So, I try to replace that p upon under root p square plus q square by sine 6 theta. Cosec 2 theta I am writing as 1 upon sine 2 theta. Q upon under root p square plus q square I write as cos 6 theta. And then sec 2 theta I write as 1 upon cos 2 theta. Now just take LCM and simplify it further. What you will have? You will have sine 6 theta cos 2 theta minus cos 6 theta sine 2 theta. Recall formula. Sine A cos B minus cos A sine B. Was it not sine A minus B? Yes. So that sine A minus B, my A is 6 theta and B is 2 theta. So this becomes sine 6 theta minus 2 theta upon, and then denominator sine 2 theta cos 2 theta. Outside part still same. Now sine 6 theta minus 2 theta is sine 4 theta. Now there has to be some connection between that 4 theta and 2 theta also. Yes. So denominator is 2 sine 2 theta cos 2 theta. 2 sine A cos A type. And that was nothing but sine 2A. So denominator is sine 4 theta. And hence the expression becomes under root p square plus q square sine 4 theta upon sine 4 theta. Sine 4 theta will get cancelled and you will be left with under root p square plus q square. Now that plus minus I have just carried further because frankly we have not taken care when we replaced sine 6 theta and cos 6 theta by by p upon under root p square plus q square, etc. That time we did not know that 6 theta lies in which quadrant, and hence we kept on writing that plus minus all throughout. So the expression's value what I have found is plus minus under root p square plus q square, and check what that answer is. Is it not B? So the correct option is B. Now realize this, that multiplying and dividing by something, this is extremely, actually if you ask me, trivial step. I mean, anyone who has little mathematical inclination will think of multiplying and dividing by something or adding and subtracting something. I mean, these are trivial tricks, but their effect is actually awesome. I mean, the kind of effect we had here, that I could replace that by sine 6 theta later or cos 6 theta, that actually did its job. So I think this question is clear to you, and then I move to next. Next one is ABCD is a square and P is a point inside it such that angle PAB equal to angle PBA equal to 15 degree. Which of the following statements is true? And then 4 statements are regarding triangle PCD, triangle PBC and triangle APT, etc. Now obviously we will have to draw some figure for this, and nowhere it has been mentioned that what is length of the side of the square. Now whenever such question comes, now choice is yours. If you wish, you can call length of one side, since it's a square, so length of a side is A, or you may write it as even 1. Nothing wrong. What will happen? Somewhere, suppose some length is A by 3, then if you are naming that as 1, I mean that length AB, if you are writing as 1, then that instead of A by 3, you will say 1 by 3. So obviously everything will go in the proportion. What I am trying to say, when names are not given, and if you are trying to name something, and then if too many names also if you give, then things may go at times out of control. So I mean, some mathematical sense you can use and name some sides, angles, etc. So I am saying that without any loss of generality, I can write length AB as 1. And then also some construction you will have to make. Like I have dropped perpendicular from P to the sides AB and CD, and I have named the feet of the perpendicular as M and N respectively. I mean, with this much little construction, I proceed further. Also, as I said, that position of P is not known to me. So I say PM is X. If I say PM as X, then what would be PN? Will it not be 1 minus X? I have not shown in the figure, but you can write on your own. PN is 1 minus X. Also, M would be nothing but, due to symmetry of the figure I am saying, M would be nothing but midpoint of AB, and N would be midpoint of CD. So if required, length MB, length AM, they can be written 1 by 2 because you have taken AB as 1. Fine. I proceed from here and I say tan 15 degree would be X upon 1 by 2. Why do I say so? PM upon AM. PM you have assumed as X, and AM just now I said it is 1 by 2. And hence tan 15 degree you are writing as 2x. In terms of X, I have written the tan 15 degree. Fine. Also, we have to actually talk about some triangle. So I start with triangle PCD suppose. And there I find that if I name angle PDN as alpha, then can I write tan alpha from there? And tan alpha would be PN upon DN, right? And what would be PN? It would be 1 minus X. And what would be DN? It is 1 by 2. So this reduces to 2 minus 2x. So tan alpha is 2 minus 2x. 2x you have already found. And that 2x is nothing but your tan 15 degree. So tan 15 degree, like in your previous classes, how you had sine 30 degree, cos 30 degree, etc. Tan 15 degree is a standard value. And tan 15 degree is 2 minus root 3. Substitute that 2 minus root 3 there and your answer is root 3. Now tan alpha is root 3. Means what must be alpha? Alpha must be pi by 3 or 60 degree. Now similar exercise you could have done from angle PCN also. And then if I name that as beta, then tan beta would have been again root 3 and beta would have been 60 degree. Now when two angles are 60 degree, obviously third angle of the triangle is also 60 degree, and hence triangle PCD is an equilateral triangle. I hope everybody understood. I mean, small somewhere actually we have used trigonometry. Question looks more of actually geometry, if you ask me. If you have any other method, I mean from geometry I'm saying, you are free to proceed further. I am nowhere compelling that you have to use only trigonometry. But I took this question because I felt that at least you will have in your notes somewhere that value of tan 15 degree is 2 minus root 3. Also at this point, I don't mind telling you similarly like tan 15 degree, tan 75 degree also here onwards we may be taking as the standard one. And answer for that is 2 plus root 3. If anyone wishes to find out actually how the tan 15 degree or tan 75 degree we find out, you can take help of 45 degree and 30 degree, because 45 degree minus 30 degree will give you 15 degree and 45 degree plus 30 degree will give you 75 degree. So if you wish, you can derive on your own that how I have written tan 15 degree as 2 minus root 3. And answer for tan 75 degree would come as 2 plus root 3. I mean, this is a good exercise for the beginners. Now, this question is okay. I think everyone has understood. Now, figure I kept in front of your eyes for so much time. Idea is this, that allow that question to get absorbed in your mind. Fine? Now, from here, we proceed to next question. Before I proceed, just check which choice you are going to mark. And the answer would be equilateral triangle means answer A. So, let us proceed from here for the next. And the next one is, if x plus y plus z equal to pi and tan x tan z equal to 2 and tan y tan z equal to 18, then tan square z equal to, and we have been given some 4 options and we have to pick up the correct one. When you look at the question, x plus y plus z equal to pi is given, tan x tan z equal to 2 is given, tan y tan z equal to 18 given, means somewhere tan x tan y tan z are involved, x plus y plus z is pi, and that actually prompts that recall formula of tan x plus y plus z. And if you recall, it was of the form tan x plus tan y plus tan z minus tan x tan y tan z upon 1 minus, and then write in the bracket sum of the products taken 2 quantities at a time, like tan x tan y plus tan y tan z plus tan z tan x. Frankly speaking, now x plus y plus z equal to pi is telling me that tan pi is 0, means numerator in the formula has to be 0. So tan x plus tan y plus tan z is tan x tan y tan z. Keep that in mind, and then I start with the problem. Now, instead of writing all the time, you must have realized now that every time tan x tan y tan z I have to say so many things. I prefer to write in terms of ABC. I name tan x as A, tan y as B, for only for convenience I am saying. If you want, you can continue with the quantities tan x tan y also. If I name them as ABC, then what I am given is AC equal to 2 and BC equal to 18. And also, we have just now mentioned that I know the result tan x plus tan y plus tan z equal to tan x tan y tan z whenever x plus y plus z is n pi. Now, from here, I will try to write something, and that is A plus B plus C is ABC if x plus y plus z is pi. Fine. Now, divide by ABC everywhere, and then what will you have? You will have something like 1 upon BC plus 1 upon CA plus 1 upon AB equal to 1. Out of AB, BC and CA, answers for AC and BC are known to me, and hence I can evaluate AB from there. And that AB turns out to be 18 by 8, means actually 9 by 4. And go for A square, B square, C square. How do I write A square, B square, C square? By multiplying AB to BC to CA. And out of these, all 3 values are now known to me. I know just now I have evaluated AB also. So substitute values of AB, BC and CA, and then you get A square, B square, C square as 81. Question is regarding tan square z. That means we want to find out C square. That means if I divide this 81 by A square B square, I would get answer for C square. And that is what I do in the next step. C square equal to 81 upon A square B square. Substitute AB whole square there, and then you will get answer for C square as 16. So I have found C square equal to 16, and that is nothing but your tan square z. So tan square z equal to 16 I have found, and hence the correct answer is 16. Now understand, all 3 questions were different from one another. And here also actually in trigonometry you will find, I mean, sky is the limit. The kind of variety you find in trigonometric questions like functions, I mean, it is unbeatable. So realize this, that all types perhaps we may not be able to take here in problem solving sessions. But questions which look different, I mean, they are not exactly as like school level or maybe college level. Those questions only generally we try to take here. So keep revising things. Meet me in next session. Till then, stay tuned. Thank you.